This video is about understanding and interpreting velocity time graphs. So let's go through the theory first. Velocity tells you how quickly an object is going in what direction. Speed only tells you how quickly it is going, so not in which direction. Velocity is a vector quantity. It has both magnitude and direction. Speed is a scalar quantity. It only has magnitude. Speed is the magnitude of velocity. So in other words, speed is equal to the positive, so magnitude of velocity. So take the positive value of the velocity. In this lesson, an object will always be moving along a straight line, so there are always two directions, forward, which is positive, and backwards, which is negative. Okay, so this is a velocity time graph. So imagine we have somewhere here an initial velocity, which is u, and a final velocity, which is v, and the time in between, which is labeled as t. Then the gradient is equal to change in y over change in x, which is equal to v minus u over t. Now we know that that is obviously the formula for acceleration. So therefore, gradient is equal to an acceleration in a velocity time graph. So the first thing you need to remember. Now if I want to find the area under the curve, area under is, if it's a rectangle, it will just be velocity times time. Now velocity times time is obviously equal to displacement, as velocity is equal to displacement divided by time. Therefore, the area is equal to, area under is equal to displacement. So area is equal to displacement in a velocity time graph again. So gradient is acceleration, area is velocity. So the only other thing very briefly I want to go through is an acceleration time graph. So here on the y-axis you've got acceleration, on the x-axis you've got time in seconds. Which part of the graph shows acceleration? So acceleration is when it's positive. So if I call this part of the graph A, this part of the graph B, and that part of the graph C, then which part of the graph shows acceleration is the first part, which is A, because acceleration is positive there. Deceleration is when we have negative acceleration. So that means it's part B. Constant velocity is when acceleration is equal to 0. Acceleration equals 0. Therefore, it must be part C. Negative acceleration is just deceleration. Therefore, it must be part B. And negative deceleration is just positive acceleration, which is part A. So acceleration is a measure of how much velocity is changing. Just going to highlight what is important. This means it can affect both the speed and the direction of motion. In this topic, you'd only look at motion along a straight line, so only two directions are possible, either forward or backward. So always remember we're moving forward or backward for this unit. An acceleration of 2 meters per second means the velocity of a particle increases by 2 meters per second every second. An acceleration of 2 meters per second squared, means that the velocity of a particle increases by 2 meters per second every second by 2 meters per second per second. For example, if a car has an initial velocity of 6 meters per second and an acceleration of 2 meters per second squared, then 1 second after its velocity it will be 8, after 2 seconds it will be 10 meters per second, and after 3 seconds it will be 12 meters per second. If a particle has negative acceleration but a positive velocity, then it will slow down to a stop, then move in the opposite direction with its speed steadily increasing. So if you think about it, imagine something is accelerating by the length of the arrow, then it'll eventually come to a stop and then move backwards. But as it's moving backwards, it will start increasing in velocity. Take care with the word deceleration. It is probably better not to use it. Use negative acceleration instead. Take care that the units of this acceleration are always meters per second squared. Okay, let's go through a question. First question, what is the acceleration in the first 3 seconds? So acceleration is equal to the gradient in this case. So A is equal to V minus U over T. So V is this point, which is 12, minus U, which is the initial, which is 0, over the time it takes to get from 0 to 12 is 3. Let's write the units here, which I'll list off, meters per second and second. So 12 over 3, which is equal to 4 meters per second squared, because it's acceleration. After how long did the object change direction? So changing directions is when obviously velocity goes from positive to negative. So you can see that happens at 10 seconds. So 10 seconds. What is the total distance traveled by the object? So the total distance is equal to area under curve or graph. So that means it's going to be the area of trapezium A plus the area of trapezium B, which is equal to area of A plus area of B. So that is area of A will be half of A plus B times H. So that's A is 10 plus B is 4 times the height, which is 12, plus the second trapezium is half of A plus B. So A plus B are the two parallel sides. So it's 8 plus 4 times the height, which is 8, which works out to be 84 plus 48, which is equal to 132 meters. Now it's distance, so it doesn't matter which way it's traveling. Work out the area of each one, and then we add it together because the distance, which doesn't have direction. 4. Work out the total displacement of the object after 10 seconds. After 10 seconds, it's just the area of A. So area of A, and it's all positive, so it's just the positive value, which is equal to 84 meters. B is after 18 seconds, because B is going in the opposite direction, and we were looking at displacement, then it's going to be area of A take away B, because A is in the positive direction, but B is in the negative direction, so we have to subtract it off. So it's going to be 84 take away 48, which is equal to 36 meters. Question 5. Draw an acceleration time graph for the motion of this particle. So that means acceleration, time in seconds, acceleration in meters per second squared. So acceleration was 4 for the beginning part. So up to 3 seconds was 4. Okay. And then from 3 to 7, maybe I should do it in a different color, then you can see it. So for 3 seconds, acceleration was 4 because we calculated in question part 1. For between 3 to 7, the velocity does not change, so acceleration is 0. Okay, from 7 to 10 is the same gradient as before, but it's in the negative direction. So that means it's going to be -4. So if I put -4 here, then between 7 to 10, it's -4. But actually, if you look at it, it goes all the way up to 12 and is -4. So it's going to be all the way up to 12. Oops, undo. All the way up to 12 is -4 because that line goes all the way, starts here, ends up there, all the way at 12. So 7 to 12 is -4. And then 12 to 16, it's gone back to no change in velocity. So it's going to be 0. Acceleration is 0. And then from 16 to 18, it goes from 8 to 0. So it's 8 divided by 2, which is 4 again. So 4 again. Okay, let me make sure it's... If you want to put lines here, you can. So acceleration is 4 here. Acceleration is 0. Acceleration is -4. All the way down, acceleration is 0. Acceleration is 4. That's it. Okay, next question. The diagram shows the velocity time graph of the motion of a cyclist riding along a straight line. She accelerates uniformly from rest to 8 meters per second in 20 seconds. She then travels at a constant velocity of 8 meters per second for 40 seconds. She then decelerates uniformly to rest in 15 seconds. Find the acceleration of the cyclist in the first 20 seconds of motion. So A, acceleration is equal to the gradient, which is equal to change in V over change in T, which is equal to 8 over 20, which is equal to 0.4 meters per second squared. The deceleration of the cyclist in the last 15 seconds of motion is, again, acceleration is equal to gradient, which is equal to change in V over change in T, which is equal to, because it's going down, velocity goes down by 8, is -8 over 15, which is equal to -0.53 recurring meters per second squared. See, the displacement from the starting point of the cyclist after 75 seconds. So that means displacement is the area under graph, which is the area for trapezium. So it's going to be half of A plus B. So A plus B are the two parallel sides. So it's going to be 40 plus 75 times by the height, which is 8. For 9 to calculate out, you get 460. Because velocity is meters per second, that will be meters. Next question. A train starts from station X and moves with constant acceleration of 0.6 meters per second squared for 20 seconds. The velocity it has reached after 20 seconds then maintained for t seconds. The train then decelerates from its velocity to rest in a further 40 seconds, stopping at stopping at station Y. Sketch a velocity time graph to illustrate the motion of the train. So we've got acceleration and we've got time. So velocity will be equal to change in velocity is equal over change in time is equal to acceleration. So change in velocity, because it's starting from rest, it must be acceleration times change in time, which is 0.6 times 20 seconds, because it starts from t equals 0 to t equals 20, which is equal to 12. So 12 meters per second is, in the first 20 seconds, the velocity would go from 0 to 12. So that means so velocity in meters per second, time in second. So in 20 seconds, it goes up to 12. Do 12. So in 20 seconds, it goes up to 12. Yep. And then for a further t, so this is only up to undo. So only up to t, it maintains the same. So it maintains the same speed. The train then decelerates from this velocity to rest in a further 40 seconds. So that means here, this must be 40 seconds. So that must be t plus 60. So this point must be t plus 60 seconds. Okay, so that would be my sketch. Given that the distance between the stations is 4.2 kilometers, find the value of t. Okay, so distance is equal to area under graph, which means 4.2 kilometers, which is equal to, because we have it in meters per second, so it must be, we have to convert it to meters, so it's 4,200 meters. So that means 4,200 meters must be equal to half of a plus b. So this is a and this is b. So a is just t and the bottom is just t plus 60 times by the height, which is 12. So that means 4,200, that's not right meters, we don't need the units, is equal to half times 12 is 6 times 2t plus 60. We divide by 6, we end up getting 700 is equal to 2t plus 60, which means 2t is equal to 640, which implies t must be equal to 320 seconds. C. The distance traveled by the train while it is moving with constant velocity. So the constant velocity is only this part of the graph. So we're trying to find the area of this part of the graph. So distance traveled with constant velocity is equal to just the area, shaded area, which is equal to t times 12, 12t, which is equal to 12 times 320, which ends up being 3,840 meters. Okay, next question. A particle moves 100 meters in a straight line. The diagram is a sketch of a velocity time graph of the motion of the particle. The particle starts with a velocity of u meters per second and accelerates to a velocity of 10 meters per second in 3 seconds. The velocity of 10 meters per second is maintained for 7 seconds, and then the particle decelerates to rest in a further 2 seconds. Find the value of u. So what we do know is it's moved 100 meters, so distance is equal to area under graph, which means 100 meters must be equal to area under the graph is there's 3 sections. So let's call this A plus B plus C. So first part A will be half of, because it's a trapezium, A plus B, so it's going to be U plus 10. U plus 10 times by the height, which is 3. Plus the middle part is 7 times 10. 7 times 10 is just, oops, I should have written down. 100 is equal to A plus B plus C. So 100 is equal to half of U plus 10 times 3, plus B is just 7 times 10, which is 70, plus C is 10 times 2 divided by 2, which is just 10, which means 100 is equal to, let's just say 1.5 U plus 10 plus 80, which means 20 is equal to 1.5 times U plus 10. 20 divided by 1.5 is the same thing as 40 over 3 is equal to U plus 10. So U is equal to 40 over 3 take away 10, which is equal to 10 over 3, which implies U is equal to 10 over 3 meters per second, which is equal to 3.3 recurring meters per second. B, the acceleration of the particle in the first 3 seconds of motion. So acceleration is equal to the gradient, which is equal to change in v over change in t. So remember, it was 10, the final velocity is 10, the initial velocity is what we just worked out, which is 10 over 3, all over the number of seconds, which is 3 seconds, which works out to be 20 over 9 meters per second squared, which is 2.2 recurring meters per second squared. A particle moves 451 meters in a straight line. So I know that's the area under the curve. The diagram shows the speed time graph illustrating the motion of the particle. The particle starts at rest and accelerates at a constant rate of 8 seconds, reaching a speed of 2 u meters per second. The particle then travels at a constant velocity speed for 12 seconds before decelerating uniformly, reaching a speed of u meters per second at time t equals 26. Find the value of u. So A, again, because we've been given the distance, so we know distance is equal to area under graph. So if we split it up, it's A plus B plus C. So that means 451 is equal to A plus B plus C. So let's work out each one individually. So A must be half times 2u times 8. Half times 2u times 8 is area of a triangle. B must be just the area of a rectangle, so it's 12 times 2u. And C is a trapezium, so we have the 2 parallel sides, which is half times A plus B, which is 2u plus u, times the height in between, which is 6. So we need to simplify this. So 451, half times 2u times 8 just gives you 8u. 12 times 2u just gives you 24u. Half times 6 is 3. 3 times 3u is 9u. Which means altogether we're getting 8u plus 24u plus 9u, which is 41u. Which implies u is equal to 451 over 41, which is equal to 11 meters per second. The distance moved by the particle while its speed is less than u. So while its speed is less than u means it's only this part. So if I just draw it out, it's going to be, it's less than u is here. So that's the only part that's less than u. Everything is above u. So the area of this triangle, so B, distance while speed is less than u. So what we do know is because u to u is halfway between 0 and 2u, this must be 4. Okay, because it's proportional, which means if I want to work out what the area of this triangle is, this red triangle, is equal to half times 4 times u, which is half times 4 times 11, which is equal to 22 meters. A car is being driven on a straight stretch of motorway at a constant velocity of 32 meters per second. When it passes a velocity restriction sign S warning of roadworks ahead and requiring speeds to be reduced by 22 meters per second. So the driver continues at a velocity for 2 seconds after passing S. She then reduces her velocity to 22 meters per second with constant deceleration of 3 meters per second squared, then and continues at a lower velocity. So draw a velocity time graph for this. So this is velocity in meters per second and time in seconds. So a car is driven, so constant velocity of 34. So if we label this 34, then it's traveling at 34 meters per second. The driver continues at her velocity after 2 seconds, for 2 seconds after passing S. So that 34 goes on for 2 seconds. After 2 seconds, she reduces her velocity to 22 meters per second with a constant deceleration of 3 meters per second squared. So we know if we use the formula A is equal to V minus U over T, then we know how long it takes for her, because we know the speed drops from 34 to 22, but how long does that take to happen? So the deceleration is minus 3. It's a deceleration of 3, so acceleration is minus 3. The final velocity is 22, and the initial velocity is 34 over time. Okay, so minus 3 will be equal to minus 12 over 3, which implies t is equal to minus 12 over minus 3, which is equal to 4 seconds. So that means from 2, after 2, 4 seconds, if you increase 2 by 4 seconds, you get to 6. So that means at 6 seconds, it drops to, let's say, 22 somewhere here. Okay, so the labeling, the arrow might not be in the right place. What we just need to do is label this as 22, okay? So that, and then it goes on, I think, continues at a low velocity, so there. So that's how it would look like. Okay, B. Find the shortest distance before the roadworks that S should be replaced on the road to ensure that a car driven in this way had its velocity reduced to 22 meters per second by the time it reaches the start of the roadworks. So that means I need to work out the area of the graph before, as soon as it hits 22 meters per second. So that means, so distance, shortest distance is equal to A plus B. A is a rectangle, so it's 2 times 34. 2 times 34 plus B, which is area of a trapezium, which is equal to A plus B is half times A plus B, which is 34 plus 22, times by the height, which is the space in between, which is 4, which is 68 plus 112, which is equal to 108 meters. So minimum distance of 108 meters needed to ensure that the velocity reduces to 22 meters per second by the time it reaches the roadworks, the start of the roadworks. A train starts from rest at station A and accelerates uniformly at 3x meters per second squared. until it reaches a velocity of 30 meters per second. For the next t seconds, the train maintains this constant velocity. The train then decelerates uniformly at x meters per second squared until it comes to a rest at station B. The distance between the stations is 6 kilometers and the time taken from A to B is 5 minutes. Okay, so A, let's draw a velocity time graph for this journey. So velocity time in seconds, velocity in meters per second. So it's accelerating uniformly at 3x meters per second squared until it reaches a velocity of 30 meters per second. So that means 30 meters per second. At some point, we don't know what this point is, where the time is equal to t1. And because acceleration is equal to 3x, then 30 over t1 must be equal to 30 over t1 must be equal to 3x. Do we need to write that? Let's forget about writing that. Okay, the train then, sorry, what was the next one? For the next t seconds, the train maintains a constant speed, so velocity. So that up to t maintains a constant. And then the train decelerates uniformly at x meters per second squared until it reaches rest. So that means it's decelerating. We know this is t2. So what we do know, part B, should we do the... So what we do know here is, if we want to write it out now, let's just write it in red. Then we know acceleration is the gradient. So 30 over t1 is equal to 3x. And this one is negative 30 over t2 is equal to negative x. Using the acceleration part. Show that 40 over x plus t is equal to 300. So we know, all together we know the distance is 6, which is the area under the curve, and the time taken to go from A to B is 5 minutes. So that means all of that, t1 plus t2 is equal to 5 minutes. 5 minutes is equal to 5 times 60, which is 300 seconds. So what we do know is t1. So we know 30 over t1 is equal to 3x, which implies t1 is equal to 30 over 3x, which is equal to 10 over x. In a similar way, we have negative 30 over t2 is equal to negative x, which implies t2 is equal to negative 30 over negative x, which is equal to 30 over x. So that means total time, which is 300, must be equal to t1 plus t plus t2, which means 300 is equal to 10 over x plus t plus 30 over x, which means 300 is equal to 40 over x plus t, which is what we're trying to prove for part B. So that's done. Part C, it says find the value of t and the value of x. So we have to use a distance here. So distance is equal to area under graph in a velocity time graph. So that means I need to work out the total velocity. So total distance is 6,000 meters. So 6 kilometers equal to 6,000 meters. Must be equal to the trapezium rule. So it's going to be half. So this is my A. Whoops, undo. This is my A, this is my B, that's my T. Half of A, which is equal to T, plus 300 at the bottom, the base, times by the height, which is 30, which means 6,000 is equal to 15 T plus 15 times T plus 300. So if I divide by 15 now, 6,000 divided by 15, gives me 400 is equal to t plus 300, which means t is equal to 100 seconds. So I need to find t. Now I need to find x. So substitute t equals 100 into 40 over x plus t is equal to 300, which means 40 over x plus 100 is equal to 300, which means 40 over x is 200. So x is equal to 40 over 200, which means x is equal to 0.2 meters per second squared. D. Calculate the distance travelled at constant velocity. Distance at constant velocity is equal to this part of the graph, so everything under the part where it's straight, which is equal to 30 times t, which is equal to 30 t, which is equal to 30 times 100, which is equal to 3,000 meters. E. Calculate the time taken from leaving, so this is that part, from leaving A until reaching the point halfway between the stations. So halfway between the stations means it's somewhere going to be, it's somewhere here. We don't know what this value might be. Let me just do it in a different color. Somewhere here, the area of the red part must be equal to, the half of the distance, which is 3,000 meters. So first thing I need to do is work out the area of the triangle, the area of the triangular part. So area up to t is equal to, up to t1, up to end of t1. So the triangular part only, which is equal to just the triangular part, is equal to t1 which is equal to, t1 is equal to 10 over x, which is 10 over 0.2, which is equal to 50. So area of the triangle, so this is 50, this is 100, so this is 150. Okay, so that means it's going to be 50 times 30 divided by 2, 50 times 30 divided by 2, which is equal to 750. So the other part, the rectangular part, area of that part must be equal to 3,000 take away 750. Because the area of the triangle is 750. So 3,000 take away 750 is equal to 2,250. And if I want to work out how much time it represents, then all I need to do is 2,250 divided by the height, which is equal to 30, gives me 75 seconds. That means I need to only go up to 75 here to get a total area of the trapezium to be 3,000. So that means so 50 plus 75. So 50 initially from that part and only up to 75 here. So altogether the time will be equal to 50 plus the 75, which is equal to 125 seconds. So we just needed to find out how much along t we need to go in order to get a total distance of 3,000 meters. A car is moving along a straight road with constant speed 17.5 meters per second squared per second. At time t equals 0, C passes a lay-by. At time t equals 0, a second car D leaves the lay-by. Car D accelerates from rest to a speed of 20 meters per second in 15 seconds and then maintains a constant speed of 20 meters per second. Car D passes car C at a road sign. A. It says, on the same diagram, draw draw a sketch speed time graph to illustrate the motion of the two cars. So we've got velocity, which is meters per second, and time, which is seconds. So car C starts with 17.5. Car C, all it does is just travels at 17.5. So this is car C at 17.5. Car D leaves the lay-by. It starts from rest and then accelerates to 20 at some point at 15 seconds. So here it's 15 and it goes to 20 meters per second, and then it maintains this constant speed. So that's how my velocity time graph would look. B, find the distance between the lay-by and the road sign. Okay, so at some point, remember, car D passes car C. Now, the common mistake is people think that that's where they pass each other, which is incorrect. That's the point where the speed is the same. It doesn't necessarily mean they're passing each other. So don't make that mistake. So we know that car C and D pass each other after D has gone to 20 meters per second. So let's just draw a line here at some point, which is here. They will pass each other. And let's call that T. Let's call that T seconds. Oops. So T here. So we know that the area under D must be equal to the area under C, which is here. So area under graph of C must be equal to area under So area of C is just 17.5 times T. So that's, let me just draw it out. So green must be equal to the yellow. So green is 17.5 times T, so 17.5 T. Area of the yellow part is a trapezium, so it's going to be half of the base is T, the set of parallel lines. This part is T take away 15 times by the height, which is 20. So 17.5 T is equal to 10 times 2T minus 15. So 17.5 T is equal to 20 T take away 20 T take away 150. So that means 2.5 T is equal to 150. So T is equal to 50 divided by 2.5, which means T is equal to 60. A motorcyclist M leaves a road junction at time t equals 0. She accelerates from rest at a rate of 3 meters per second for 8 seconds and then maintains the velocity she has reached. A car C leaves the same road junction at M at time t equals 0. This car accelerates from rest from rest to 30 meters per second in 20 seconds and then maintains a velocity of 30 meters per second. C passes M as they both pass a pedestrian. On the same diagram, sketch velocity time graph to illustrate the motion of M and C. So if we've got velocity and time. Okay, so acceleration is equal to v minus u over t. So we have acceleration is 3. We don't know the final velocity. We know the initial velocity is 0 over time, which is 8. So velocity is equal to 3 times 8, which is equal to 24. So that means motorcyclist M accelerates from rest to 24 meters per second. So that means 24, if I draw 24 here, in 8 seconds, so up into 8 seconds. And then maintains the velocity she has reached for the rest of it. So this is the motorcyclist. Just make it straighter. So this is M. Car C leaves the same road junction at time t equals 0. The car accelerates from rest to 30. So let's put 30 here. So rest to 30 in how many seconds? In 20 seconds. So 20 seconds goes to 30. And this is the car, and then it maintains a velocity of 30. So that would be it. Find the distance of the pedestrian from the road junction. So B. So if I call this somewhere here, let's call this T. Somewhere here, the time that they meet. So what we do know is area under C, which is this one, must be equal to area under M. Oops, undo. Make sure I go up to the red line. So area under graph of M must be equal to area under graph of C. So M is half times A plus B, so that's T plus T minus 8 times 24 must be equal to, let me just draw that, and that one is equal to that, must be equal to half of the area under the yellow part, which is T plus T minus 20 times by the height, which is 30. So it's 12 times 2t take away 8 is equal to 15 times 2t take away 20, which is 24t take away 96 is equal to 30t take away 300. If I collect all the t's in one side, I get 6t is equal to 204, which means t is equal to 204 divided by 6, which is equal to 34 seconds. It says find the distance of the pedestrian from the road junction. So we weren't trying to find out what the time was. We were trying to find out what the distance was. So the distance is just one of these. So distance is either one of these would work. So distance is either 24t minus 96. So either this one or this one, whichever one you prefer. So let's just do 24t minus 96 is equal to 24 times 34 take away 96, which is equal to 720 meters. A car is traveling along a straight horizontal road. The car takes 120 seconds to travel between the two sets of traffic lights, which are 2,145 meters apart. So that is the area under the graph. The car starts from rest at its first set of traffic lights and moves the constant acceleration for 30 seconds until its speed is 22 meters per second. So if I were to sketch this, let's just start sketching. So velocity in meters per second, time in seconds. So it goes all the way up to 22 meters per second. Undo. It goes up to 22 meters per second in 30 seconds. Okay. Let's try to draw it a bit more straighter. And the car maintains a speed for t seconds. So that means the same speed for t seconds. So this must plus t plus 30. And then moves with constant deceleration all the way up to there. We were given the fact that a car takes 120 seconds to move between, so this is 120. Okay, so that's it. We've done the sketching. Next part is find the value of t. So this is A. B is find the value of t. So this distance is area under graph, which is equal to K1.2 is equal to half of, again, this is a trapezium rule, so A plus B. So A plus B, the base is 120, and the top part is just T times by 22, which means it's 11 times 120 plus T. If I divide 2145 by 11, I get 195 is equal to 120 plus T, which means T is equal to 75 seconds. A motorcycle leaves the first set of traffic lights 10 seconds after the car has left the first set of traffic lights. So 10 seconds after. So 10 seconds after. The motorcycle moves from rest with constant acceleration 8 meters per second and passes the car at point A, which is 990 meters from the first set of traffic lights. So something like that. Okay, when the motorcycle passes the car is moving with 22 meters per second. So that's drawn right. Find the time it takes the motorcycle to move from the first set of traffic lights to the point A. So what we do know is at some point, this is T, the time T. So this is, up to that point is T. So the area under the trapezium, which is this part, must be equal to 990. So area C, area of must be equal to 990. The area of the trapezium is equal to half of T plus T take away 30 times by 22 must be equal to 990, which means 11 times 2T take away 3 must be equal to 990, which means 2T minus 30 must be equal to 990 divided by 11, which is equal to 90, which means 2T is equal to 120, which means T is equal to 60 seconds. So that means time is equal to 60 seconds, but the motorcycle moves 10 seconds later. So time for motorcycle must be equal to 60 take away 10, which is equal to 50 seconds. D is find the value of A. So what I need to do is first, so if I look at this triangle, then I know in that triangle 900, so area of triangle must be equal to 990. That means 990 times half. 990 must be equal to half times the velocity, which we don't know, times by the time, which is 50. Which means 990 must be equal to 25V. So V must be equal to 990 over 25, which is equal to 39.6. The velocity is 39.6 at 39.6 meters per second. So the acceleration is changing V over changing T, which is equal to 39.6 over 50, which is equal to 0.792 meters per second squared. Okay, just to summarize what we learnt, note the following points about velocity time graph. The gradient of velocity time graph is given by change in velocity over time, which is equal to acceleration. You have to be careful in interpreting the sign of the gradient. If it is positive, then either the velocity is positive and is getting more positive, i.e. speeding up, or it's negative and it's getting less negative, i.e. slowing down. If the gradient is negative, then either the velocity is positive and it's getting less positive, i.e. slowing down, or the velocity is negative and it's getting more negative, i.e. speeding up. A straight line on a velocity time graph indicates that the acceleration is constant. If the gradient is positive and the acceleration is positive, if the gradient is negative, then the acceleration is negative. A horizontal line on a velocity time graph indicates that the velocity of the speed is not changing, i.e. the object is moving at constant speed. And the last point is parts of a velocity time graph below the time axis indicate that the velocity is negative, i.e. the object is moving in the negative direction, although the displacement may still be positive.